Good afternoon, everybody. Today I'm going to talk about the various tooling ecosystem that are present with Apache CloudStack. A bit about myself. I'm currently working as a QA engineer at Shapeblue. I've been involved with CloudStack since 2013 by providing technical support to various customers who are using CloudStack in the world. I'm also an open source enthusiast. I love to try out new products, new releases, and play around in my free time. I'm also edited to various podcasts and audiobooks also. So this is the agenda for the talk. I'm going to talk about the different CloudStack APIs and different orchestration management tools, different Kubernetes tools that are available, observability tools that are available, and the performance benchmarking tools, and give a short demo of each tools and leave it up for questions. Starting, the best feature about CloudStack is the API. Sorry, it's very well documented. Every section or every resource has got its own APIs. Suppose you got a virtual machine, there are separate APIs for VMs, storage there are APIs, networks, so there is an API. It is well written. It can be, if you want to integrate any product, the first thing is to look at the API documentation, see how you can integrate your product with CloudStack APIs. This is the, as you know, if you compare with any hyper cloud like Amazon, Google, they have got its own CLI tools. AWS has got EC2 tool, CLI tool that you can interact with AWS APIs. Google Cloud has its own tool. So even CloudStack has its own command line tool. So it's written in Go language. It has got support variety of features. The main thing is you got to provide the API credentials like API key and secret key and install this tool, and you can play around with all the CloudStack APIs. It supports auto completion, and it's one of the best ways to interact with the CloudStack. Coming to the configuration and orchestration management tools. How many of you use tools in your day-to-day life? Like, what are the popular tools that you guys use? Anybody? Like, can you give some examples that you are currently using? Terraform. Okay. Sorry? Ansible. Okay. Okay. Cool. So CloudStack supports all the popular open source tooling system currently. We support. So what is main purpose of orchestration tools? You need to have some kind of file in particular way after a machine comes up. Then basically these tools generally reduce your time savings. You're bored of your manual tasks and you want automation to be done. So you got to use these tools for your day-to-day activities. All these tools are agentless, so they don't need an agent to be installed on the operating systems. And all these tools are idempotent. That means they help in configuring the server or operating system to be in a specific state. And let's take a look about each of these tools. So Cloud-init is one of the first orchestration tools that was in the market. It was originally developed by Ubuntu, and CloudStack supports Cloud-init via user data feature. So if you look at the how the CloudStack uses Cloud-init. So CloudStack, whenever you launch a VM, the operating system like Ubuntu or CentOS, they need to have the Cloud-init package installed. And the template, when you register the template in the CloudStack, and during the boot process, you pass in the Cloud-init configuration. As you can see, the first suppose you go install Apache package or Nginx package. When the VM boots up, you need not go manually install. It's a repetitive task. So Cloud-init, when the VM boots up, it contacts the CloudStack resource virtual router where all the user data Cloud-init scripts are there, and it configures the operating system with that particular package. So we have improved compared to other hyperscalers. We have improved the Cloud-init feature in CloudStack. So we support various ways of Cloud-init user data in cloud. We can mention the user data during VM deployment, and the user data is a first class feature. Like there's a separate section in CloudStack UI where you can store the user data and associate them to a particular template or ISO, and later use the template during the VM deployment to use a particular Cloud-init script and We support Jinja based formats, but I don't know whether other AWS and Google Cloud they support Jinja, but we do support Jinja for Cloud-init based user data. Next is the popular tool that everybody uses, that is Ansible. So Ansible is one of the popular configuration management system tool. Where do you want to use Ansible? So basically we are using Ansible. Suppose CloudStack installation setup could take a lot of time to get the system and running. So we can use Ansible to speed up the installation of CloudStack management server, hypervisors like KVM. You need certain packages to be installed on a system. So we can use Ansible to get the things ready in a quick time. So CloudStack, this is the high level flow. Suppose in a management server, they need a lot of database installation, certain packages to be installed. We can write there's already existing CloudStack playbooks, Ansible playbooks that you can use in your environment and set up a CloudStack environment quickly. Next comes Terraform. So Terraform is one of the popular HashiCorp tools that every cloud is using to deploy infrastructure resources, right? So in CloudStack there is a Terraform provided for CloudStack, through which you can deploy resources on CloudStack easily. Like you want to deploy a VM to Terraform network, and it is very easy to deploy resources from Terraform. We just need to run Terraform apply, and the resources are deployed on CloudStack. So next, so this is the general overview. We got well documentation on Terraform providers. So every resource has got what are the parameters it has to use, and you can run Terraform apply and the instances are deployed. Next we have the Packer tool from CloudStack. So you should be generating a lot of golden based images, right? Suppose you have got a requirement that particular two teams out there, they want to deploy some application on the image when the VM boots up. So this generally requires a lot of manual effort. So Packer helps in creating golden image creations in CloudStack. So how the Packer generally works is it contacts CloudStack, builds up a VM, install the necessary packages, creates a template in the CloudStack so that next users can use the golden image. And these are some of the features, benefits of using Packer tool, and I am sure all the public clouds support, and we also support the Packer tool. So this is the general code for sample code that we can use. There is a provider for CloudStack and Packer also, so we can use of the tool. Next, coming to Kubernetes tools. Currently we support there are two ways to deploy Kubernetes clusters in CloudStack. One is the native way of using the CloudStack Kubernetes service, and the next is the cluster API tool to deploy Kubernetes cluster on CloudStack. Cluster API is very popular tool on the Kubernetes community. So currently using cluster API we can deploy multiple clusters in all the clouds. So AWS, GCP and Azure. Similarly using cluster API we can deploy clusters on Kubernetes, Apache CloudStack. So these are general benefits of using clusterized, like we can support multi-cloud. If you got even managing, if you are using a hybrid environment in your organization with respect to Kubernetes, you can have one cluster in AWS, one cluster internally in your lab, and it supports versioning, GitOps workflow, and a lot of features. So the general overview of a cluster API, how it works. There is generally a management cluster that holds the CloudStack related configuration information, and from there from the particular Kubernetes cluster we can contact each individual cloud and deploy a Kubernetes cluster on particular cloud. Next, coming to the observability and monitoring tools that are available right now. CloudStack is well integrated with Prometheus and Grafana. So we are observability is one of the most talked about in these days trends. If you want to know how the system is performing, you want to how the metrics of the VM are there doing, and alerts and notifications, you got to get notified to the users. By default, CloudStack has a metrics feature on the UI, which provides valuable insights into the VM's disk stats, network stats, and CPU information. But if you are not satisfied with the inbuilt picture of CloudStack, we can always use Prometheus or Grafana to get the metrics data. So this is currently, these are the various metrics that Prometheus is supporting for CloudStack. We can add more metrics based on the requirement. And we can easily integrate. We just need to enable the setting in the global setting, and Prometheus metrics of generated, and Prometheus can scrape the metrics, and we can directly beautifully visualize from in the Grafana dashboard. So, and Grafana can also be integrated with the CloudStack database if you want to analyze the, if you want to get more granularity into the workings of a CloudStack. Next, coming to the benchmarking tools available for CloudStack. Currently, we have released a CS benchmarking tool, which is if you want to test the performance, how much time a particular API is taking, how much load it is taking for a particular. If you want to distribute the load across and see, you can identify various bottlenecks in this CS benchmark tools. This will be a little bit clear when I give the demo. So, like when you can see the time, how much time a particular API is doing, and how much time it taken to destroy, and those things. So, let me quickly give a demo of each tool. So, okay. First, let me show the Terraform tool. So, I got my Terraform files. Suppose I want to deploy a CloudStack instance and a disk, volume disk, and network. I just mentioned the requirements in the Terraform file, and I mentioned the secrets and keys that it has to contact the CloudStack. So, I do Terraform init. So, now it is installing the Terraform provider for CloudStack, and now I will do Terraform apply. So, coming back to the UI, you should see a VM that gets launched soon. Oh, sorry, I didn't to give yes. Sorry. So, it is creating the network, it is creating the VM and the disks and attached to the disk. So, it will take some time, I can.
We can use this Terraform code to, this as a use case, you can use it for creating a DR site.
Yeah, so currently the question is like you can use the Terraform tool to automate more things. Right now, if you look at the Terraform documentation, these are the resources we support.
There's complete infrastructure you can.
Yeah. So, if you want whatever the tool, the DRS tool, we should have a resource that supports the automation activity. Currently, we are planning a new Terraform release shortly in another 2 months, so which we can add the features. So, as you can see in the demo, the VM is starting up via Terraform, it is running, and I can again run Terraform, and it cleans up again. Next, coming to Packer. So, the requirement is this is it follows the similar HashiCorp language to create golden images. So, So this Packer script, suppose I want to, the base image of Ubuntu is there. I want a particular application, say Docker, to be installed on that Ubuntu golden image. So I written a Packer script. So basically it goes and installs Docker and generates a golden image that people can use. So now I can say Packer build, and it will basically use a base template. So basically it uses this default Ubuntu template, spins up a VM, installs Docker package, and creates a another template based on the image. So basically it should now, right now it has spinned up this particular VM. Now it is booting and installing the Docker package, and let's see, it is just waiting for search. I can meanwhile it may take some 4 minutes time to do this activity. Let me show the csbench tool, performance measurement tool. So basically, if you look at the csbench, there is a config file that we are going to specify. Basically, you want to create how many number of VMs and test the time it is taking, how many domain, or what are the time it's taken to create the list, execute a particular API call, and I can say yes. So now it will create some dummy domains on your CloudStack environment. So basically, you can see the dummy domains it has created. Basically, the tool is stress testing your CloudStack environment, and you can plan how much, if you want to add more resources in your, how much time it is taking, and improve the performance of your CloudStack environment. So yeah, now it is, this Packer is running. It is coming to the observability tools right now. So basically, you need to get the Prometheus data. We need to just go to global settings, enable Prometheus, and provide the Prometheus server IP so that you can reach out to CloudStack and get the metrics. So right now, if you, this is my Prometheus server, and if I give, so right now this is my CloudStack server and it is up and running, and I can get the various CloudStack, these are the various metrics that are available, and using Grafana also we can query the Prometheus metrics that are coming from CloudStack. So I go to dashboard, and we can select the various CloudStack metrics that are available. It generates beautiful dashboards based on the requirements. So right now this is a csbench tool. So it has created domains in 4 seconds, VM in 44 seconds, gives you real performance metrics. So let me see the Packer. Packer is still creating. Yep. And we can similarly execute the teardown of the resources once the performance test is done. Yeah, I forgot to do demo about the cluster API. So yeah, so let me create some Kubernetes clusters through cluster API. First, I need to create a kind cluster. So this will spin up a management clusters through which we can launch another other clusters on public clouds. So basically, once this is done up, so now you got a cluster running. So you can get. So this is, let it take some time to come up. Where is my? So once this is done, we apply a configuration. This contains the credentials of the CloudStack, so that the cluster API can interact with the. If you look at the credentials of this YAML file, basically it contains the API keys and of the CloudStack environment. Once that is done, we need to install the CloudStack module for the cluster API. It's a little bit slow. Okay. Yeah. Let me see if the packer is ready. If I go to images, see, it has created this Docker template via packer. So if I so it has done, it has shown the CloudStack Docker template is created. Now I can launch a VM based on the template it has created. Yeah, now this is coming to this cluster API. The next step is to give some environment variables so that it can reach out to CloudStack and use these resources to create the cluster. Now it generates a spec file. So if you look at this spec file, so basically the cluster ETL tool or CAPC to API tool will deploy these resources on CloudStack based on this NFL. Now let's apply. Let me see if the pod is running first. Yeah, it's still creating. Once it's done, we can apply that. So now this Docker is running. There's a password. So Docker is installed, you can check. Yeah. Let's see this. And now let us apply. So once this is done, you can describe your cluster on CloudStack with this command. So it basically, if you come back to the CloudStack environment, it will start creating. I just need to delete them so that it will create a control node and a worker node, and it should create a cluster slowly. Yeah, so right now you can see this control node that is coming up. And once that two nodes are ready, we can download the kube config file and try to interact with the cluster. Apart from that, like you can see, we got the metrics by default in the CloudStack. We have got good observation system that comes up. But if you want to use Prometheus or Grafana, we can use that also.
Come again, please. Sorry.
So this provides nice metrics view, right? This is inbuilt in CloudStack. You need not use another tool like Prometheus to get the data of a particular VM. But if you are not satisfied, you can use other tools, Grafana also. And coming to the user data, like this is particularly a password. You can just register user data in this format, and the VM picks up the particular installation or creation of the resources on the VM. So basically, and we can attach this user data to a particular template. So we can attach different user data, different configurations on the template, and VM will pick up the configuration. And
This is different from the golden package.
yeah, this is another tool, Cloud-init. Golden template is a packer thing that is also available in other public clouds to create customized images. Yeah.
So this is similar to same kind of activity.
Yeah, it's the main difference between Cloud-init and Packer is like it has got its own versioning. You can more control. It's an infrastructure as tool. You can see the code, and Cloud-init is like configuration, like similar to OS configuration on booting level itself, like Ansible. Yeah.
Kiran, may I add to your
Yeah.
question there? So I think earlier, I think a few of you were talking about how can I implement database as a service. The problem with customized template is for every type of workload you have to create a golden image. So one with Packer, one with Docker, one with MySQL, one with GitLab, one with WordPress. You'll have so many templates, so many versions to manage. One way to work around that is you have a golden base image. So base image that you maintain, and user data as a first class feature that you maintain separately. So during the VM deployment, you can select I want to use base Ubuntu, but then I want to use user data that installs MySQL or installs GitLab or installs WordPress. So this is sort of a way where you can have any application as a service without having multiple images. And what Kiran was trying to show earlier is that this user data can accept parameters. So for example, during deployment of your instance, you can create a user data that takes in inputs. Like you want to deploy MySQL, and here the variable is the username and password. So during the deployment of MySQL server, it will ask you, okay, give me the username and password. That way you can create any application as a service and customize it to your advantage. And you can use it to automate a portal where you say, okay, I want to give database as a service. So you write a UI on top of CloudStack that leverages these APIs, and you can accomplish an offering like any application as a service. Just to give an example of what people are using these features for.
So right now we can see it has pinned up the control and worker node. I want to get the kube config file so that I can interact with the Kubernetes cluster. And once this config file is there, let's apply the networking part. So once it has installed the networking CNI plugin, we can get the nodes, make sure they are running. So it is installing the CNI plugin. Once the CNI is up and running, the nodes will be in ready state. It should be there. Yeah, now it should. So this is the way, using cluster API tool, we can deploy Kubernetes cluster easy, and we can manage them if you have got a hybrid environment. Yeah, I've done the demos. Any questions? Yeah, the question is whether we have good documentation for Packer and Ansible. Yeah, similar like Terraform, we have got documentation for. Let me show you the Packer documentation. So if you, these are the parameters that Packer supports for each for CloudStack, and how you can use them. And for Ansible also there is good documentation. Yeah, let me see. I got the resource link in my slide once. Yeah. Okay.
So here, whatever the tools you are using externally, so can you see those tools as a services CloudStack?
The question is whether you want to see the tools integrated in the CloudStack UI itself, right?
As a service.
As a service. I don't think any other cloud is doing that, right? It's all part of your.
For AWS, for Kubernetes, EKS cluster is EKS service is there.
Yeah.
For Git repository, for GitHub like that, we have cloud repositories there.
Yeah.
Like this way, for if you want to maintaining any database, RDS service is there.
Right.
So here also Ansible, Packer. So do you have the services are available in CloudStack?
Currently integration with, since there are all external components that are not managed by CloudStack at least, they have their own vibrant communities, and people are working with, so it's difficult to integrate on with the CloudStack, but we can, you can open a GitHub request and we can take it up if you really want that.